We're going to be practicing what seems to be a stumbling block for some students when it comes to dealing with projectiles that are fired above the horizontal and off of a cliff. They seem to have a difficult time finding time and air for the projectile. Now, if you do not want to use the quadratic formula, this is the method that you are going to have to use for class. Please do not piecemeal together the time. It is valid and that does work, but I want you to understand that you can find the time and air for the projectile in just one fell swoop, in one shot, and realizing what is happening. Okay, so looking at the diagram, we see that the projectile is going to land 15 meters below from where it was fired. So that means your y displacement is going to be a negative 15 meters. Remembering that wherever we fire a projectile, we treat that spot as the origin of an XY coordinate system. So anything that's below you is going to be negative. Remember, plus and minus is directional. Have to deal with projectiles in terms of vectors. So the first thing you're going to have to find is your velocity initial in the y direction. So using velocity initial in the y equals velocity initial sine theta initial. So our velocity initial in the y, we get from our initial velocity, which was 22 meters per second, and our initial angle, which was 32 degrees, will give us a velocity initial in the y direction of 11.66 meters per second. Now next, we want to find our velocity final in the y direction as we strike the ground. So when we do this, we're going to use velocity final in the y squared equals velocity initial in the y squared plus 2ay. Now we're looking for velocity final in the y. And as we've talked about before, with this equation, it doesn't involve time. So your plus or minus, you have to decide if the projectile is on its way up in the y direction or on its way down in the y direction. The equations that involve time, if you do them correctly, the plus or minus, the direction part, comes out for you. Now this one, thinking about this, the projectile is heading toward the ground. So in the y direction, it is heading in the negative direction. That means we are going to have to take the negative square root. So to get velocity final y by itself, I take the square root of each side. And on the left-hand side, since a radical is actually a 1/2 power, because of your exponent rules, the square cancels on the velocity final in the y. So I end up with velocity final in the y equals, so velocity initial in the y, still squared, because of that plus sign, you can't distribute that 1/2 power. Square root of the entire thing, make sure everyone's in the radical, and I have to take the negative root, showing that my velocity final in the y direction is heading downward. And now for my numbers with my units. So velocity final in the y equals, I have 11.66 meters per second. Square that. Use parentheses because not just the number is squared, but the units are also squared. 2 negative 9.81 meters per second squared. I'm going to run out of room. Negative 15 meters. Squeeze that in. Take the square root of all of that and make sure I take the negative root. So my velocity final in the y direction, and when you do this, you watch your order of operations, will be 20.74 meters per second. Alright, so just knowing that the projectile lands below where it was fired, I have to make that direction negative. I know my acceleration due to gravity, and for all projectiles, it's always negative because it's pointing toward the Earth. I have my velocity final in the y. Now I'm going to use this to find my time in the air. For that, I'm going to use velocity final in the y equals velocity initial in the y plus a t. Alright, I need to solve this for time. So I'm going to subtract velocity initial in the y from each side. And I'm going to divide by acceleration, each side. And on the right hand side it goes to 1 and it stays on the left. Now from here I'm going to put in my numbers. I have my velocity final in the y, not forgetting that it's negative 20.74 because it's on its way down, not on its way up, minus my initial velocity, which was 11.66 meters per second, and then I have negative 9.81 meters per second squared, and my time is 3.3 seconds because I'll have negative on the top, negative on the bottom, negative divided by negative is positive, and you should always get positive time. So this is the method you need to use to find time for a projectile that's fired at an angle above the horizontal and off of a cliff if you do not want to use the quadratic formula. So in just one shot, two steps, you have the time of the projectile in the air. Please do not piecemeal it together by finding the time to the top, and the time back where you came from, and time to the bottom. Just do it all in one step. Okay, that's it.